Audible?
Yes, you are audible.
Uh,
Start.
uh, BTech from NIT Patna, CISA 2005 and CISP 2012. So more than 20 years, I would say 25 years experience in this field. So I'm just trying to cover a very pertinent topic today, which is OT versus IT security. And OT security, we have guidelines which is freely available, NIST SP 800 82R3. So I'll just start. So basically, I'm trying to compare OT versus IT. Like OT systems are mostly autonomous, isolated, and they run on mostly proprietary software. And IT systems, as you all know, connected, they lack autonomy, and they are operating popular operating system like iOS and Windows. But there is a change here. Like SCADA systems are now moving to virtual servers, like on which is basically it was earlier used to be on a separate hardware. Now we have hardware on which we have virtual servers. So more or less, IT is now coming into the picture. OT also. And since IT is there, so they will start. The expectations are there to start monitoring and controlling OT systems remotely by the internet. There is again an issue. And then since we have an IT functionality added up, so people want to operate OT devices, that is CS, and other uh, uh, performance monitoring. And like initially, if you go back 30 years back, then they had little resemblance of IT systems because they were isolated and running mostly on proprietary control protocols using specialized hardware and software. But now with Ethernet and IP and wireless devices, now they are actually replacing older proprietary technologies. So this actually has got functionality, so like it's more easy to operate, but then it's adding the cybersecurity vulnerabilities and incidents which are part of IT. So it's basically more or less resembling IT systems because we are adopting IT technologies to promote corporate connectivity and remote access capability. These are actually bringing the vulnerabilities of remote access and corporate IT setup. This integration supports new IT capabilities but provides significant less isolation for IT from the outside world than predecessor systems, creating a greater need to secure them. So the air gapping concept also was there earlier. So this is good, uh, being taken out. So basically, security solutions have been designed to deal with these issues in typical IT systems. Special precautions must be taken when introducing these same solutions to OT environments. In some cases, new security solutions are needed that are tailored to the OT environment. So basically, if since OT and IT were separate, but since with the advantage of IT technology, OT servers are moving on to virtual servers. Routers, which we're using in IT, are the same in OT. But the vulnerability also are basically carried into the new system. So those things needs to be taken care of. So typical differences now I'm trying to compare here that OT has many characteristics that differ from traditional IT systems, including different risk disparities. Like this OT controls health and safety of human lives. And if something happens to the OT system, it can cause serious damage to the environment and financial issues, production losses, life losses, and everything. OT has different performance and reliability requirements and uses OS and applications that may be considered unconventional in a typical IT network environment. And security protection must be implemented in a way that maintains system integrity during normal operations as well as during cyber attacks. So there, basically now I will be comparing OT versus IT on the based on NIST standard finding. So there we'll see the exact difference. So basically, IT we can go for rebooting. OT we can think of rebooting a oil pipeline or a hospital system. So that the rebooting option is not there, and they have to be in a perfect standby. So at least through primary, secondary, tertiary, there are many. Sometimes we have two standby system in OT system, which is not there in IT. So I have taken out this IT versus OT differences from NIST standards freely available. It's a very enriched one, and the latest one I have taken. So this basically is a guide of OT security. It's available, and I request everyone to go through it. And basically, If you come to the next slide, yeah. So as I was discussing the typical difference between IT and OT systems, the performance requirement. In case of IT, it's high throughput, but OT, it's real-time response is time critical, like ticketing business. If you talk about hospital or talk about any power plant, so response has to be there. And in case of IT, high delay and jitter may be acceptable, but in case of operation technology, it's not. And similarly, the response to human and other emergency interaction is very critical, and access to OT should be strictly controlled, so not hamper or interfere with human-machine interaction. Like if the system feels that human HMI has to come into picture, but that option we don't require in IT. But in case of OT, as I said, the system has to be running 24/7, like 365 by maybe 20 years or 15 years. Sometimes these things have to be continuously on. So that aspect has to be there, which is discussed in the next one, which is availability, reliability. As I discussed earlier, response such as rebooting are acceptable in case of IT, but in case OT, it's a big no. Similarly, availability deficiencies can often be tolerated depending on system's operational requirement. We'll say sometimes say 99.9%, 99.1% availability. Here it has to be 100%. So that is discussed here, like how does it must be planned and scheduled days or weeks in advance. High availability requires exhaustive pre-deployment testing, and availability requirements may necessitate redundant systems, which I discussed. Sometimes there are three systems which are designed. Rebooting cannot be acceptable. Risk management requirements manage data confidentially integrity in paramount. Here, physical world, human safety is paramount, followed by protection of the process. So confidential integrity may not score high in this case. Fault tolerance is less important. Momentary downtime is not a major risk. Here it is. Fault tolerance is essential. Even momentary downtime may not be acceptable. And the major risk impact is delay of business operations. The major risk impact are regulatory non-compliance, environment impacts, and the loss of life. Equipment protection is the biggest issue in case of OT. So systems operations here again, I was discussing it like the IT system uses typical OS, Microsoft or Linux. In this case, they use different, possibly proprietary hosts, sometimes without security capabilities built in. So I was discussing, but there is a change now. Like now, the SCADA software, SCADA system, they also have understood the efficiency of a virtual machines. So sometimes what they do, they have 3 physical servers and they put virtual machines on that. So it's certainly convenient for all of us, but then that brings in the issues of typical OS, issues of maybe Windows or Linux. So that patching option has to be thought of. And in case of OT, the software tech changes must be carefully made by the software vendor only because of the specialized control algorithm and potentially modified hardware and software involved. So those are issues. Then resource constant, yes. In case of OT, the systems are designed to support the intended industrial process and may not have enough memory and computing resources to support the addition of security capabilities. Like in case of easily, you cannot upgrade it, you cannot add capacity into it. In case of IT, it's not a big deal. You can easily add resources. Enough resources are already there inbuilt, and you can add on also. Communication, standard IT communication protocols are used, and primarily wired network with some localized wireless capabilities. Typical IT networking practices are required in case of IT. In case of OT, many proprietary and standard communication protocols are used. And several types of communication media are used. I will try to explain with an example in the next few slides, including dedicated wired and wireless, radio and satellite, and complex network exists that sometimes require the expertise of control engineers. So then, here I want to explain, emphasize here there are 2 important points here. Like the lifetime of a component is 3 to 5 years. It is in this case is only 10 to 15 years. The patching, obsolescence, and if you have different components, then upgrading them and then testing them is a big issue here. And components are usually local and easy to access. And here it can be isolated. In fact, in case of a pipeline or in case of a clip grid, it is across all along the pipeline or RVO or electrical grid. Like can be isolated, remote, and require extensive physical effort to gain access to them. So it's just summarizing like what it does. Basically, collect measurements and status data from the process. I'll try to maybe explain with an example. And remotely intervene in the process with the feedback getting from the site. It can intervene, shut down the process, or start the process. Can be done with the help of SCADA capability. Centralized system platform everything comes centralized, and then you have a distributed IO system working here. Am I fast? So let's slow down a little bit.
No, it's okay. It's
It's
okay.
okay. Okay. So basically, as it said that it's basically used for a distributed system, water distribution, wastewater collection system, oil, natural gas pipeline, electrical utility transmission, and distribution system. So here we don't have a luxury of keeping the system in a controlled environment. They are in the field, sometimes controlled, sometimes not controlled, and field instruments are actually in a totally controlled environment. I'll explain. And the data is collected to analog and digital. I think that it's coming in the next slide. Yes. So that is called uh, RTU, remote terminal unit, is is a unit which is called, and it takes data from the field devices and then it sends it to the PLC where it takes decision. It's basically designed to be fault tolerant, significant redundancy. I have seen normally it is designed with 3 levels of redundancy, which is not there in case of IT. It's normally 2. So again, trying to make it more clear, like getting from field, collect consolidation of information, then visualize, share, process, and then respond. The most important is respond. You can sitting it here in Noida or any place, you can shut down valves, pumps, anywhere in the world. So that facility is making it convenient, but it's also adding the aspect of security and safety. Now, because the more we are converging with IT technology, the more it is become vulnerable. Now I'm going to a pictorial representation. Yes. So it's basically field devices. Field devices gives data to the PLC, and through RTU, it's come to SCADA server. And based on the data, alarms and reports it creates, trends also it creates, and then human machine interface. Sometimes automated also, like if you find that field devices there is high temperature or high pressure, then there are systems inbuilt. It can straightway send a signal to shut down the device, or human machine interface. There's an operator sitting here. He can also operate from here. So there are 4 components: field instrumentations, remote stations, communication network, and central monitoring station. We are again explaining those sensors, field devices, RTUs, and programmed PLCs, then centralized SCADA software, human machine interface. So sensors and field devices are the first instruments which basically interact. They're physical devices, they're actually physics. They are actually taking the temperature measurement, pressure measurement, and sending it to this, through analog and digital signals. And then it is processed by PLC, and then PLC sends it back to the SCADA system, and SCADA takes a decision. If there is an anomaly, it can stop. It can operate from remote. SCADA server redundancy, PLC IO, LAN network, MCC, SCC, they are master control room and secondary control room. Sometimes there is tertiary control rooms. Now, this is a slide on which I want you to be there with me for some time. This actually, there are 2 types of devices. Like one type of device actually sends analog signals, 4 to 20 milliampere, and another is digital signals, which is 0 to 24 DC voltage. So if PT is pressure transmitter, TT is temperature transmitter, and flow transmitter. pressure control valve and flow control valve. It's a typical system of a valve setup, which I'm trying to explain here. So here, this PT, TT, and FT data actually is coming through analog signal to field junction box, then safety barrier for the surge, and ultimately goes through PLC, these cards. This is analog input, analog output, digital input, digital output to the PLC controller. I'm coming back to this digital signals also. Here is pressure switch, level switch, and MOVs, motor operated valves. So here it is analog, means it from like pressure can start from say 0 to 50. So 0 will be 4, 50 will be 20. Temperature also, like flow also will be this. And PCV, FCV, here it is basically taking input PLC to RTU and ultimately SCADA, and the output is coming back through this to this PCV and FCV. So PCV is pressure control valve and flow control valve, which can be operated sitting here in SCADA. Similarly, this is pressure switch and LS switch and MOV, motor operated valve. This works on 0 and 1. So if the pressure is high, it will send an alarm, shut down. If the level is high of a loop, it will again 0 or 1, either it will send the signal to shut down or start. And MOV is motor operated valve. So it will be either 1 or 0, it will start or shut down. So these two type of signals come and they come to SCADA, and like these PT, TT or FT are input coming to this, and SCADA giving output to pressure control valve and flow control valve to operate as per the requirement of the system. Similarly, here PS and LS are giving the input through these system, and MOV is the one which is taking input from this. Now, this is safe zone because these are all wireless and cards. So nothing more or less can happen in this field. But the moment you are coming to PLC controller, then we have a TCP/IP setup for the PLC workstation. And this is it was Modbus, now it's Modbus TCP coming to the RTO remote terminal unit. From there, this DNP3 protocol, SCADA router, and SCADA. So these are critical zones. This again is a little critical. This is not critical. Because the moment you are coming back to now, you are taking input from IT here. So IT advantage is there, but IT has got disadvantage also. So we have to start working here and here. Basics, there are some minimum suggestions which I have incorporated in the end, which can be done straight away. Because here, nothing much is required. Nothing much can happen. At the moment you are coming here, the moment you're going to TCP/IP, going to RTU through Modbus, going to protocols, DNP use protocol, SCADA router, and SCADA, yes, there the possibility of breach or a misconfigured, disgruntled employee can create havoc here. Now, this is actually a station wall I'm talking about. It's a location which is far, far, far away, not a station, somewhere in the field where we have to control a wall. So there again, same thing is happening. The analog signals are coming 4 to 20 milliampere, TTTT. Here it's again only getting the input. See the difference. Here there is no wall. It's only getting the input. There's no control as such. It's only the getting the input. And this is the signal. Here is a motor operated valve which is getting the output. Now here there is a problem, right? We have field GV, IO card, RTO, LT switch, SDH port. This is basically for the PDF from LAN to OFC. There is an OFC communication. The primary communication is through OFC. It's a station somewhere sitting in a far-flung location, and it's connected through OFC. The first communication is through OFC, and the secondary is through MPLS link. So the moment you are converting your coming into LAN with SDH port and media converter OFC, you are coming into the domain of IT. It's L3 switch, router, firewall, SCADA server. There is a switch here, there is a switch here. So there, the port mapping has to be done. Otherwise, somebody can go there and if you have a SCADA software, you can start entering into the system. So this is something which sometimes is unmanned. So there, a physical control is required. It's basic thing, which I'm just trying to explain with experience. Not much rocket science. There are three cases which I'm trying to explain. One is case one is IT interface with OT, which is very, very normal, which happens every day. Like the SCADA server is there, then the SCADA engineer will come with his laptop and PC, and then he will use AnyDesk or remote access app to get support from his hierarchy. That's an issue. In case of IT, we have controls. So that is something which requires immediate action from anybody who is allowed. There has to be, uh, I would say, policies to check these things. So because he's straightway coming to the SCADA server, the nerve center of this whole system, from where the command can go to the wall, to the pressure switch, and that actually can create an issue, big issue. Case two, which is very common. Like you have a PLC or SCADA desktop PC. They are all controlled by uh, their desktops, and that desktop has an if you have an access and use your that port to maybe any USB device, that's again an issue. The physical control can take care of these issues, but these are happening. These are there, which we have find in our practical situation. So this can be easily controlled through a physical control, not allowing any USB outside. Third one is again here basically it's a login and credentials issue. This is PPC, PPLC is a process PLC, SCADA, and safety PLC. So we have for all the safety equipments, we have separate safety PLC, and for all process equipments, we have process PLC, and SCADA is controlled. And it is engineer workstation and operator workstation. Engineer workstation is there, all the configuration is being done. There again, we have to have separate login credentials required, which normally should be there, but sometimes we miss it. So immediate action is required is use of external devices if prohibited, proper security configuration of switches, router, and policy firewall, SSH configuration should be enabled, port security, and binding. Oh, I think I finished it fast. So now, this is where I am trying to take input from our IT security guidelines and then try to use it in the OT setup also. Like if the first one is identifying assets, classify them, and prioritize value. Here, let's try to go back to this. Yes. This is my typical big station, which is controlled, which is manned. So here we see that if you talk about that asset prioritization, the most important asset which can be affected very easily here is SCADA router because it is there available to everyone. So their physical controls are required. Similarly, RTU and PLC control. We have assets in these PT, TT, PS, LS, MOV, field JV, safety barrier, IO cards, but here nothing much can happen except for that physical breakage and somebody can break the wire, but nothing much can happen. Because the moment you're giving the data back, the commands back from SCADA, which is coming back from here to here, to here, the command actually comes from here, but tells this PCB, pressure control valve and flow control valve, to start controlling the pressure and flow. If it is not warranted, it can create havoc. Similarly, this MOV, it is controlled via SCADA, coming to SCADA router, RTU, PLC, then card. So this is critical zone. So this is assets needs to be identified and their vulnerability needs to be assessed. This is the first thing which yeah. So classifying and prioritizing. It's clear. Any question on this?
No, not. Anybody else?
So these are actually this is from our experience, which I'm trying to explain that there are many things available on the net, but these are the four things which we could get where actually it is very close to IT, but OT has got different issues. Like if you take if you going back to the earlier example of a field location where everything is wired, nothing much can happen. But the moment it is coming from wired, from PLC to RTU to SCADA to the router, their OT environment coming to IT is coming into picture. So it's still maturing the OT technology. They are having the vulnerabilities of IT, but it's not known. So basic requirement of a physical control will help there. Yeah. Second is typically analyze traffic for threats and vulnerabilities. Yeah. So this is typical taken from the IT world, but here also the PLC and from SCADA, because SCADA is basically on the servers are on a Windows machine with a virtual machine. So Windows patches needs to be there. Windows has to be taken care of in that case. PLC is normally, unless until you can go there and sit there, it's very difficult to actually manipulate or any of the parameters. But with, yes, SCADA is can be really servers can be compromised if you can, because it is actually sitting on a virtual server on a OS, Windows OS. So that aspect needs to be taken. Because sometimes what happens, if, from practical example, uh, the design is like you have three physical servers on which, say, eight virtual servers are there. So for any operation, critical operation, you require minimum two physical servers, say 12 virtual servers to be operational. So sometimes with our experience, we have taken for one more physical server because if it's a critical location, then we require full standby. Maybe if one complete server goes, all those virtual servers can be migrated to the second and third, and still we have got one standby. So that example I was just trying to explain here because here, if you identify asset that yes, this virtual server sitting on this hardware is very critical for me. In that case, in case of IT, you can have one redundancy, maybe a backup will survive. But in this case, it can be tertiary. We can have three, not only three here in one location, but we can have three separate locations. So in case of SCADA, the primary, secondary, and tertiary are very common. As I said, the reboot is not option. It runs 24 by 7 by 365 by 10, 15 years. But that aspect has to be taken care of. Then traffic for threats and vulnerabilities, it is basically if you can go back. Yeah. So here there's no traffic. It is all hardware. It is here traffic, this is traffic. This all can be analyzed with the help of the tool, typical ITPS tools. Control, identity, and access management. This is quite mature in case of IT setup. In case of OT, it was not required because normally it was done by with the help of the proprietary that engineer, that SCADA engineer sitting there, and he is having all the controls. But now with the help of OT, since it can be managed remotely, so all those identity and access control management needs to be done, which I tried to explain with this example of engineer's workstation and operator workstation. Engineer workstation has got all the powers, all the user credential is like an admin. And sometimes if it is controlled remotely, this, then yes, it's a big issue. So here we need to require to access control and credentials control. So the person has to be there. If physically, if he's not there, he can control remotely also, but then at least you should have control through login credentials. So normally we, in the new scenario of OT setup, it's normally the operator which does, and EWS is very sacrosanct, and this password is not shared over the wire. Secure both wired and wireless access. Yes. This is L2 switch. This is L3 switch. So if somebody, suppose SCADA is giving back to this, ultimately from here onwards, it's basically signals, digital signals and analog signals. So if somebody gets into this L2 switch, this is a, suppose it's a remote location, it's an Almira sitting, typical L2 switch. There are ports available. If somebody can get into it, use the software, and then somehow translates that signal and takes control of this MOV somewhere sitting in a, say, 200 kilometers from this location. That's a big issue. But that this can very easily be controlled with the help of a port, control of the switch, and access control. Physical security, basically. So this is typical. It's not related to safety, security only. It has got some safety aspect. Also, typical working experience which had in our setup. Like tags are properly defined and mapped to the corresponding channel of PLC. Uh, it, uh, yes. So this actually is a hardware signal from NVIDIA. So and it has to actually come into RTU. So this all whatever signal two wires which are coming here, they have to be properly terminated here. This actually is done by the field case of construction, and the person doing is may not be that much of trained. So that the moment a person, a SCADA engineer or SCADA team comes in, the first thing he does is he checks the mapping, physical mapping of that cable. So all these things are not there in case of IT work because this actual location is sitting somewhere to in a farm 200 kilometers away. So maybe manned, may not be manned. So the first thing first that yes, the signals which are coming here, the physical wire has been mapped properly. Software ranges are in line with the field instruments. So like this explained like that analog signal from 4 to 20, 0 to 20. So those things are actually mapped properly in RTU and ultimately into the PLC. Software backup is to be taken on a regular basis, normal. Panels have to be kept covered locked before powering up during construction activity. All these panels, especially in a discussing, this is discussed because in case of OT, our assets are lying open. So there the panels, which the RTU panels, the switches, they have to be covered, locked before powering up because it's not only safety but availability also. Suppose that critical the switch fails, then you have to immediately arrange for a backup. Otherwise, security comes or safety comes, but availability is the most important part in case of OT. So that also is to be taken care of. Dust-free environment and GPS time is to be synchronized. So that's all from my side. I'll come back to these three slides. Yeah. So again, cost and reputation. I just want to tell my viewers here that these are basic three cases which I had to take it, have taken from my experience, which is any desk remote access, because this is required in case of SCADA. I don't want to name the vendors, but their specialized engineers are there. They have to come and access these SCADA servers. So they require any desk, the laptop. So that proper pos- policy has to be in place. Simple USB access control will help. The two, three, four cases which I think I have time to talk about is Colonial Pipeline case, Stuxnet. So they are basically coming through IT and then touching the centrifuges of the nuclear plant. Stuxnet software, which is widely available on the internet and it should be used and again went back from Iran to US. So those things are available and they are actually first times, first time IT is actually moving into physics. They are controlling the devices actually which can control havoc, create havoc. And I would say, unimaginable catastrophe. And we are lucky that uh, India is not in the radar of these nation state, but the devices are same, people are same. So I'm just trying to give in two or three basic points which we can work here and help us go in a long way. Like basic was, first one was access control. Because straight away going to SCADA server, complete SCADA control is there. Then, as I said, the input will be there and output will be there. Output has to be based on that valve has to be when it needs to be operated is totally system based. But if somebody can get into it, they can start manipulating valve opening, which basically controls the pipeline flow. Third is typical IT control. So that here three controls. One is your access control, one is your physical USB control, and third one is separate login for engineer workstation and operator workstation. These three, if it is properly done, and one last thing which I missed out is physical control on a remote location, so that nobody should go and like right. These field instruments are kept in panels, kept in a normal almirah or where if somebody can go get into that switch and then somehow controls starts talking to those devices in their language of PLC, then he has again an issue. But again, these are basic things which can be controlled with the help of physical controls. Not much investment is required. So, yeah,
Sandeep sir, sorry to interrupt you. Atul this side.
yeah, please.
I have a very limited or basic experience with the OT security or IT to OT security because in my career, one project where I audited, I did the IT or OT penetration testing for a particular client. And basis that experience, like the point which you just bring up three, four things, I just wanted to, know your thoughts or my means basis my experience. What I've
Mm,
seen, there is a primary thing of architecture review also, which is very important because of the current scenario where IT requires to integrate with the OT environment. In the
absolutely.
legacy systems, OT was completely segregated, but with
Bilkul,
the
absolutely.
new things where IT leaders they require what is the reporting, and for that reporting they have integrated IT to OT. And
Absolutely.
that comes with a cost because OT systems they are provided from the OEMs
Yes.
and all the IT controls are not as such applicable. Like if give you I give you the example from my experience, we talk
Mm,
about patching the softwares or systems regularly,
yes. Yes.
but
Yes.
you cannot do in the OT environment because you do
Absolutely.
not know whether it is OEM supported or not. And
Absolutely.
one more thing which I have seen, like in those environment, majority of the thing is the production thing. It's not
A-
traditionally like in the IT, there is a development, there is a UAT environment, there is a prod. They have a
Absolutely.
production environment and then isolated systems where they SCADA engineers they can test for their new software or anything. It's not full grown UAT environment. They do not have that much uh,
Absolutely right.
things there. So like that is very important because in I mean I cannot tame the client, but in my experience, we successfully penetrated from IT environment sitting from Noida
Uh,
successfully to the OT environment because their reporting server was directly exposed,
oh,
and we
yes.
could completely control and get
Mhm.
into the OT environment. And once I am there in the reporting server, I can easily navigate to other systems.
Absolutely. Absolutely. Yes.
And one more thing, sir, like the access control point which you bring up, just in line with that only, what I have seen because of the low knowledge or IT knowledge or means trainings and those things, what happened? Those engineers, right? For them, the top priority is production. What is the daily production?
Yes.
The
Yes.
system is
Yes.
up and running,
Mm.
100% performance should be there. And
Yes.
for that, I mean, if an engineer is going for 10-minute break also, they may not be logging off the system. Okay. System
Absolutely.
is up and running. Anybody can go. I mean, if you have the physical access is the topmost priority. Even
Yes.
the intruders, if there is an intruder, inside threat is there, they can easily get system access because it is there. Passwords are written there. That is
Yes.
what
Yes.
I've
Yes.
seen in the environment.
Yes. Yes. Yes.
So
So,
that's what I wanted to share.
what's your good name? I couldn't get you.
Atul Patel, Atul Patel.
Atul, yes. In fact, I also cannot name the company in which I'm working, and it's good that you also have come because this is actually what you said absolutely right because uh, it has to run, I said, 24 by 7 by 365 by 15, 20 years. And as you said, there is no test, there is no, everything is production, right? So, and it is so critical that we have 3 tiers of production only. You cannot test and run it in case of IT because as you said, like 15 years, if you suppose there are many, so 4 or 5 components of this setup, SCADA is from somebody else, maybe a PLC is from somebody else. In case of this, yes, the PLC is supplied by somebody else, safety PLC is supplied by somebody else, SCADA is supplied by somebody else. So all these 4 OEMs, suppose we patch all, suppose we patch one, then how it will be interacting with other, we don't have a test bed. So that as a real issue. Now problem is all the more aggravated because of 2 points, like as you rightly pointed out. We're gradually moving IT things into OT. Like in this case, it's on a hardware physical hardware, virtual machines, and virtual machines has got a SCADA, right? So nobody has experience of how the virtual machines can operate, what are the vulnerabilities, those because they are typical OS. That is one. Second, you have very rightly said that if something happens, the top priority is production. It has to work at any cost. So there, passwords again written everywhere. And third, USB access. USB access is something which Mr. Patel already pointed out that sitting here in Noida, you can access, and sitting there in also somebody can access into. So those, yes, awareness is a must, and I think government is also trying through different forums. But I don't know. There was some problem with the grids. What happens? Nobody knows because maturity of OT and IT. The IT as a functionality is coming to the picture, but we are tending to forget here that IT shutdown can still be accepted. The Windows can reboot. It's fine, but PLC rebooting is a major issue. It's a big news for a big company. So thanks, Patel, for putting your valuable input. Anybody else?
I mean, just one last point, sir. Just to add that, I mean, I was supposed to in that project only. I was supposed to do the switch and all those audits. Okay, so basically, if you want to do the configuration review of a switch or those devices, network devices, I mean, generally how we do in the IT, we have a script which we run, and through that script we extract the output. What are the configuration settings? So when I was telling them that this is the process, this is the script which you can run and extract the output, I mean the engineers were just afraid that by running this script, it should not impact anything because even if for a minute or few hours it is impacted, it will be thousand crores of the loss, and nobody is ready to bear that. So that is what the challenges are right now. So that's why
Yes.
I mean majority what we have seen and what we have recommended also. I mean, those controls, because of the operational challenges, it may not happen, but architecture segregation and putting the architectural controls to segregate different environment in a proper manner is the top priority, so that your high availability systems, or the system which has a critical data, that should be protected adequately with the defined controls. So
Yeah, basically that's what I've tried to identify very easy, manageable steps. There is something which can be easily done. And in fact, what you pointed out, I just want to add on. We don't have asset list of 14 devices. Very difficult to find that what assets are there. In case of IT, at least we have an asset list and we prioritize, identify, and then prioritize this. It's not there in OT, not at all. So, in fact, who is the OEM getting that OEM on board to help us? So again, very difficult. I don't want to name the OEMs, but yes, it's an issue. But the problem starts with the IT coming into picture in OT. IT can tolerate shutdowns. IT can tolerate reboots. OT cannot. So then, new generation has to think because it was totally air gap earlier. But now we have there's one solution. I just because I wanted to cover in the next slide, next uh, uh, presentation when maybe next after couple of months, then I'll try to come up with the issues right which are going to come. You have IoT, you have data diodes which are going. It's a one-way communication because now management wants to get everything on their desktop, right? The data has to come. If it is a separate channel, fine, but sometimes it is coming through OT. IT channels, MPLS and all. So those things can it's fancy to get a dashboard for the director or for a chairman for the OT, but it may not be required. You only what requirement does a CEO have? No, it's basically run by the engineers there. They know the best. So what I feel is there should be some interface, some data only coming out, and it should come through data levels. Another issue which I just want to put across to gathering here is, which is called Internet of Things. That is there everywhere. It requires constant access to internet, and sometimes it requires dual going, getting information from a net and giving it back. See, giving the information to the internet is an issue. Taking also an issue. So there, the control is data diode, one way, and can go only one way. But all those things like you said, have to come into design part only. The design still is not discussing these things, critical things, addressing these critical things, which can be very easily managed by some physical control, USB control, access control, password policy. That's also not happening because we are, fortunately, we have not seen any such catastrophe happening because of this, or even if it's happening, it's not reported. So this is awareness which I thought we have to bring it to the public at large because normally IT guys only have to get into this OT because OT, as you said, they only believe in product. Their mandate is production 24 by 7 by 10 years, 15 years. And they have never thought that something of this can happen. The only thing something can break down. And breakdown remedy is something they are working, but not something which is happening on account of a vulnerability which we are familiar in IT world. We still have 10 minutes.
So, Sandeep, when you are talking about the SCADA, this is one more very renowned incident related to the SCADA attack, that Stuxnet thing. Can
Yes, yes.
you give something on that at this time?
Uh, yes, Stuxnet, I think people might be aware. So Patel, are you aware of this?
yes, yes, Sandeep ji, I am aware of that.
uh, it's actually, I think, I don't want to name the countries, right? But it's basically was trying to jeopardize nuclear capability of a nation by changing the speed of their uh, centrifuge. It could do, but it could not go that far. It was just this software is sitting there for months, and now the worst part is that software is available on internet. It has been used, redesigned, re-engineered, and used to another big nation state. So that's the problem. These things are available, and it is nation state issues right now. But another case, Colonial Pipeline, was a ransomware case. It was an IT attack going into the pipeline, Colonial Pipeline in US. 10 days shutdown happened, and that brought this thing into picture and prominence. So this is not something which is, because IT also, if you shut down, if your ransomware is there, then yes, your pipeline will be stopped. So because it is actually IT talking to physics. Whatever I was discussing about valves and all, they're all physics. They're controlling fluids, they're controlling electrical currents, analog signals, digital signals. So now they are actually interfacing. So somehow the SCADA is manipulated in such a way that it starts sending signals, which they try to do in case of that stuff. Colonial pipeline also is similar. So yes. But Mr. Patel, you want to add something on this?
No, sir, you have covered that point. That I mean, yeah, it was a very big attack, and it was having like multiple type of things. Like, I mean, not only one, it has like it was having the worm, it was having the file rootkit to
Yes.
I mean to to attack the OT environment from all the sides, not only just one thing. So yeah, I mean, it was a very big attack. It was the very big attack that
Yes.
time.
So that is actually, Paramveerji, is a big issue because as we are discussing that the priorities of IT and OT are different. IT is CIA track. Here it is CIA is not availability is most important. Availability
Yes.
and yes. So that mindset has to come. And as Mr. Patel pointed out that they don't expect such thing. They only see maybe troubleshooting for a breakdown. They have till done phase breakdown. The OEM is not coming. That OEM part is not available. Redundancy have they ever tried primary, secondary, tertiary redundancy. All those things are because it's a production system which is going to have an electrical grid which is going to collapse, a hospital which is going to collapse, or pipeline system can collapse, so refinery is going to. So fortunately, maybe we are not yet targeted, but yes, with the development this country is having, somebody may certainly try and do it. So basic things I've discussed, 4 or 5 points, which can state way start working on this. And then we have this standards, which is freely available, which can be used. And next, maybe if you get time, I can certainly work on those NIST paper and how we can use it in our policies, as you said, to Patel, from a design basic, from a design setup only.
Oh, it's just nice. Anyone else who want to ask anything? Okay, so we can conclude Sandeepji today. It was a good presentation, and I just want to know from the audience who all have worked on the actually SCADA security. Actually, I think this is not everyone's cup of tea till the time who doesn't understand the full form and understanding of all those things, he might not be able to understand. So who all have actually worked on this SCADA security actually? The people actually who have worked upon who doesn't, this is very actually a small field, niche field kind of field. Everyone is not expert, but this expertise is required. So from that point of view, this presentation was very important, and thanks for this. By
Hi,
this, hmm,
Paramveer ji and Sandeep ji. I'm Vishal Kakade. I'm working on OT security. So basically, I am working with a OEM, and yes, for new projects and existing also, when there is upgradation or migration. So we are redesigning the architecture, and we are assessing the network. As said, there are tools in market, various tool that can gather the information of OT asset as well. Okay. Uh, so, Sandeep ji, you very well covered all these points. I would like that your next session may include IEC 62443 standard or
Yes,
Purdue
yes,
model.
yes.
So
Absolutely,
that will
yes.
help to understand because I worked with IT as well as now I have shifted my career to OT security.
Mm.
So I know the security of both worlds. I have been worked with internet service providers, telecom providers, and some of enterprise setups for automobile client. So from there, now I'm in OT security.
Yes. Since he raised this point, Vishal, automobile, all these big XUV cars that you are buying that got an APN SIM chip,
Mhm.
which so from either Airtel or this. So yes, yeah,
Yeah,
I think
more of
yes,
the industry 4.0, people are focusing on this. And today also you might get a news that ransomware attack happened
yes,
to yeah, so that is we can say because as you said, rightly said, it's time to secure IoT and OT because
yes,
the traditional way of working is now getting changed because of industry 4.0 and uh, manufacturing companies also leveraging various reports needs to be there. So as rightly mentioned, data diode of thing are there to protect, and we have to first and foremost thing is you should know the your inventory because
yes,
if
yes,
you don't
yes,
have inventory, you are not sure what to protect, then it would be a difficult. So first step will be definitely getting inventory from the all the OEMs. So there are tools in market available, and now people are I can see more of Middle East and European countries. They are pretty much inclined with investing in cybersecurity. In
yes.
India, it's going on, but still the market is like budget constraints they have. But still, they are leveraging all possible options to secure it.
Yes, it's actually not a business case that is able to not actually it's making interesting. People, the board, top level man, still thinks that no, it's not going to happen to me. But if it happens, then as you said, there's no asset list, there is no policy, OT policies are not there. Nobody has thought of making an asset list if it asset inventory is not there. What is it, right? So why they will invest in all this software? So that had to be there, and we're just waiting for disaster to happen.
Okay, so time is going out. So let us finish for today. And thank you, speaker sir, for this today. Thank you,
थैंक यू
Sandeep ji.
परमवीर जी आपका
And
बहुत
thank you.
सहयोग रहा ये हमने कर दिया इसको
So, अरे हमारा actually we have completed our target for 2 webinars minimum for this Jan month. So thank you so much for getting our target completed today. Thank you all. So by this, let us finish this meeting. Okay.
थैंक
Thank
यू
you.
थैंक यू ऑल फॉर
Thank
कमिंग
you.
एंड
Thank
sparing your valuable
Okay.
inputs.
Thank you. Thank you
Yeah.
all.